Electricity and Magnetism in Future Transportation. Dylan Finney, Physics 2020, March 18, 2018. The increasing desire for use of electrical or magnetic energy in transportation is due to the desire to decrease pollution, which is created by burning of fuel. Also, the cost of fuel is increasing while the availability of it is constantly decreasing. Electricity and magnetism in transportation will also help decrease the time in traffic because of the high speeds these trains and transportations will be able to go. They will also allow us to travel across the country over high speed, close to the same amount of time it would take to fly. Overall, electricity and magnetism in transportation can decrease the time wasted going from one place to the other, along with making the environment a better place by decreasing pollution in one of the main ways possible. Current cars are still using an internal combustion engine that is filled with fuel that is burned to create energy to move the car. The important parts of this engine are the spark plug, the combustion cylinder, the air and fuel, which are found inside the container cylinder, the pistons, which are also connected to the crankshaft. The spark plug allows the fuel to flow into the valves, which then go into the combustion cylinder. Once the air and fuel are in the container together, the fuel is ignited and it helps create a compression pressure overall. The pressure is strong enough to move the pistons downward, which create a total movement in the car. Once this is done, the air can be compressed back down so that more fuel can enter, and the process is repeated to create a constant movement of the car over a long period of time. Electric motors power battery electric cars without the use of fuel. Car charging stations are increasing with the increased desire for electric cars. Outlets in the wall are still capable to be used to charge up the lithium-ion batteries seen in these cars. Controllers near the engine receive stored energy from the batteries that are charged and transfer it over to the electric motor. The electric motor now contains energy to make the car move the way the driver is expecting it to. Not only does it help with the movement, but it powers all other things in the car like power steering, the radio, air conditioning, etc. The lithium-ion batteries that are used currently don't seem to have a very long lifetime, and many chemical experiments between other lithium and other chemicals have been done to try to create a battery that can create a longer power source so that trips can be longer without fueling up at more stations. Problems with battery electric cars are seen when traveling large distances. One problem is that you have to stop and charge the car during travel about every 100 miles, which can make the travel time increase greatly. Supercharge stations could be increased throughout the states, but that could be bad for Earth if it's not done the correct way. The correct way would be done by making sure the amount of energy being drawn from the Earth with all the extra charging stations, especially those that are supercharging and can charge a car within 30 minutes, could be too much for the electrical grid we currently have. Researchers have not come up with a good idea yet on how to make these stations the most economically efficient for everyone and Earth, so most people who do switch to electric cars keep at least one fuel-powered car around so that travel trips can be more easy. Magnetic levitation trains using electromagnetic suspension. This train has magnets all around the sides of it like a box. These magnets are electromagnets that repel off the bottom magnets that are seen on the rails below it and at the side walls. The sidewalls have conductive materials in a loop formation with a layout of alternating poles. This layout causes a repelling and attractive force to be seen, and this propels the train forward. The magnets on the rails below the train are opposite in pole to those on the bottom of the train. This will make sure that they will repel one another, causing the train to levitate. This levitation decreases tension and allows the train to travel at very high speeds. The levitation, along with the attractions from the side walls, allow a decrease in the amount of crashes trains will have when coming around corners quickly. Magnetic levitation trains using electrodynamic suspension. This type of train uses supercooling at a temperature of -450 degrees Fahrenheit, which allows for a stronger magnetic field to be produced. Superconducting magnets have a weird characteristic where the superconducting magnets gain energy capability when they are cooled to a certain temperature. Supercooling is an expensive process, so some believe the electrically charged magnetic levitation trains spoken about before are economically better than this version. The pros of this version is that if the power fails, this train has the energy to continue running on its own. Its magnets also levitate using the guideway of the car. This allows the tension to be decreased and the train to move at very high speeds to get to one location from the other as fast as airplanes. Another version of magnetic levitation trains is seen in the Inductrack version. This version uses neither cooled superconducting magnets or powered electromagnets. Instead, it uses permanent room temperature magnets that can create the magnetic fields rather than the charged coils of the side walls seen before. These permanent magnets levitate over passive coils, which causes a reduction in tension and allows the train to also travel at high speeds as seen before. These speeds are not as high as seen in the supercooling version because that version creates the highest output of energy possible. A downfall of this version is that it cannot outpower if the power fails. If the power does fail, it can slow down and safely stop on its auxiliary wheels, but that is all. NASA and magnetic levitation. NASA is trying to create an affordable way to build a special ramp alongside a mountain. It will be open at the bottom of the mountain and end at the top of the mountain with the exit hole. This ramp will contain components of the magnetic levitation trains used to operate, but it will most likely use the supercooling version to get the most force created. It will propel a space shuttle through a tube up a mountain using the properties in the tube to levitate the shuttle. The levitation properties will decrease tension and allow the shuttle to move at quick enough speeds that will be able to propel it quick enough that it can reach Earth's low orbit. It will make space travel less expensive and environmentally better without burning fuel into the environment and decrease risk of failure. NASA and magnetic levitation continued. NASA has also paired with a company and hopes to create a magnetic levitation form of public transportation called Skytran. The energy here will not be received from fossil fuel. Instead, it is received from the kinetic motion of the vehicle and solar panels placed on the vehicle. Levitation is used to decrease friction, which will be created by magnets in the car pod itself. The energy will be cheaper because it does not require many superconducting expensive wires or the supercooling mechanics that are also expensive and seen in the magnetic levitation trains. It will also allow you to get on anywhere at any time, ride alone in a quiet space over traffic, high speed to make it at quicker times, and it only stops at your destination rather than many times along the way, which is seen with regular public transportation. Volvo's involvement in transportation advancements. Volvo has also been interested in magnetism and the future of transportation with self-driving cars. They are especially interested in how the cars know where they are on the road and the correct speed to go and how to change lanes and make turns. They are trying to glue magnets all along the road about 10 centimeters apart that will be able to send the car system a signal under a certain speed that can calculate the car's position within these 10 centimeters between each magnet. They believe the magnets are less obstructed by bad weather and road conditions compared to electronic transmission. This is why they believe the magnet should be used rather than electronic transmission, which is also a more tedious but cheaper version compared to the electric wires that would be ran throughout the roads to create the electronic transmission version. One of the main purposes that electric and magnetic sources have becoming increasingly used in transportation is to deter from the polluting. This polluting is created by non-renewable resources such as fuel being burned into the environment, whether it's through industry work, transportation, power generation, or more. The diagram above can show how pollutants enter the air, are cycled through the top layers of the earth, and make it back to earth either in the same form or in a new polluting form. Using other sources of energy seems to be the major way, if not the only way, to decrease pollution seen in the environment.